First conic section we will see the circle. So we have a cone. In this case, the cutting plane will be perpendicular to the axis of a cone. So this is the axis of a cone, this is the axis of cone, and this is the cutting plane. So in this case, the conic section will be a circle. So the conic section will be a circle. So this section is a conic section. Conic section means the intersection of a cone and a plane is a circle. So important thing is, when are we going to get the conic section as circle? So whenever the cutting plane, so this is a cone and this is a cutting plane. So whenever the cutting plane, this is the cutting plane which intersects the cone such that the angle between the axis of a cone and the planes, let's say beta, is 90 degrees. So let's define beta. We'll define beta as a angle between axis of a cone and plane. Okay, let's have a general beta is between axis of cone and plane, and we have already discussed the notation alpha, that is the angle between axis of a cone and a generator. Okay. So in this case, we observe that whenever the beta is equal to 90 degree, that is the plane, the cutting, this is the cutting plane. So whenever the cutting plane is perpendicular to the axis, so whenever this cutting plane is perpendicular to the axis of a cone, that give rise to a circle. Okay, the conic section, that is the section between a cone and a plane, is a circle. So obviously this is a non-degenerate case. Why non-degenerate? Because the cutting plane do not passes through the vertex of a cone. Okay, same thing if suppose this is a cone and our cutting plane obviously is a perpendicular, so we assume that our cutting plane is perpendicular to the axis of a cone, but they passes through the vertex of a cone. Or if we make it again, so this is the cutting plane. Okay, they are passes through the vertex of a cone. So this is the cutting plane, they passes through the vertex of a cone. In this case, the conic section, in this case the conic section is this is a point, and this is a degenerate conic section. So obviously beta is equal to 90 degree has two, one is the circle, other is the point. What is beta? Beta means the angle between the plane. So this is the axis of a cone, and in this case this angle beta is equal to 90 degree. So beta is equal to 90 degree give rise to a circle or a point given the cutting plane passes through the vertex of a cone or it do not pass through the vertex of cone. So if the cutting plane do not passes through the vertex of a cone, it give rise to a circle, and that is a non-degenerate case. Whereas the point, when the cutting plane passes through the vertex of cone, and that is a degenerate conic section. Okay, so suppose this is a cone. Okay, we already know that this is a cone. So we'll see how come the intersection of a cone and a plane is a circle? So let's we draw a plane. Yeah, so this is a plane. So observe that this is a cone, so this is a cone, and the plane is perpendicular to the axis of a cone. So let us, this is the axis of a cone. So we observe here that the plane is perpendicular to the axis of a cone, that is beta is equals to 90 degree. So here this plane and this cone, they are just this plane and this axis of a cone, and this plane is perpendicular to the axis of a cone. Okay, so in this case, let's see what is the intersection. Okay, so yeah. So we observe that the intersection is a circle. The intersection of a plane and a cone is a circle. Let's move the position of a plane. So as we move the position of a plane with respect to a cone, we are getting a circle of different radius. Okay, so this is a perfect circle. And we observe that as we move the plane away from the vertex of a cone, the radius increases. So this is a plane, and whenever this plane moving away from the vertex, this is the vertex of a cone, the radius of a circle increases, and at the vertex of a cone, the radius of a circle tends to 0, and that becomes a point, and actually that is the degenerate case. We observe that the intersection of a plane and a cone is a, so this is a plane, this is a cone, this is a point, and in this case we observe that the plane is passes through the vertex of cone, so that is a degenerate case. So in this case, see, this is a plane which is passes through the, so this is a cutting plane which passes through the vertex of a cone. So that's why we are getting a intersection point, or the intersection conic section between the plane and the cone is a point. So this is a point, this give rise to point, whereas in this case, whenever the plane do not passes through the vertex of cone, they give rise to a circle. And mind it, in this case also the angle between the plane and the axis is 90 degree. So the figure which is shown here is this degenerate case, whereas if the plane move away from the cone, so in this case this plane is now a non-degenerate conic section, because they are moving away from the vertex. So beta is the angle between axis of a cone, and the generator is 90 degree. They give rise to a circle, or they give rise to a point, and we already discussed circle means non-degenerate conic section and point is a degenerate conic section. So I'm ending the class here. Next we'll see the parabola, hyperbola and the ellipse.